This video will cover the learning target. I can explain how electron shielding affects the atom. So to understand electron shielding, you have to understand a lot of different terms and ideas of what's going on in the nucleus. So first and foremost, the nucleus is positive. We've talked about this before. Since all you have in the nucleus are protons and neutrons, overall that charge is positive. Now, in terms of nuclear charge, it increases then every time you add a new proton. So if you look at any atom on the periodic table, carbon for example, carbon has more nuclear charge than boron because it simply has more protons. So nuclear charge increases as we add more protons. The problem is there's also something called electron shielding. And electron shielding is essentially that when you have a full energy level, so like on the table I often think about it as having a full row, right? I filled like my S's and my P's and my D's. It can be that I just fill a sublevel, like a full S or a full P might have an effect on this. But usually we're talking about filling like a whole entire row, like all of the 3s or all of the 4s. Those act as a shield against the electrons feeling the nuclear charge. So really why we care about nuclear charge is because the electrons are being attracted toward the nucleus, right? But it turns out that even though I'm adding protons, the attraction of the electrons toward the nucleus can become less as I add more protons because I'm also adding more electrons. So this picture kind of depicts what's happening for electron shielding. And we're going to use the Bohr model to depict it just because it's easy in our brains to think about like a full energy like orbit being filled. But obviously this is not what actually happens in terms of the locations of electrons. So if you imagine like that you have a full energy level, okay, like a Bohr ring. What's happening there is electrons that are outside that ring are being attracted toward the nucleus because of nuclear charge, but they're also being repelled away from the electrons that are between themselves and the nucleus. And that's the electron shield. So the electron shield is an increase in repulsion that exists when you have full energy levels between the valence electrons, which are the outermost electrons, and the nucleus. This learning target asks you to understand what the effects are of shielding. The number one effect of electron shielding is that there is a reduced effective nuclear charge. That's what it's called. So nuclear charge is the charge in the nucleus. Every proton that's being added increases your nuclear charge. Effective nuclear charge is not just based on how many protons are there, but how well the electrons are actually being attracted to the nucleus, given the fact that a shielding exists. So essentially, we have a decreased effective nuclear charge because of shielding. So even if I have 10 protons in the nucleus, which is more than 4, those 10 might have a decreased attraction for the electrons because of an energy level shielding between themselves and those valence. Okay, so that's one effect of shielding. The other effects on shielding is it affects all of the measurements that we're going to talk about in this unit. So it affects ionization energy, it affects electronegativity, and it affects atomic radius. And the truth is it affects all these things because all of these things, all of these measurements depend on the proton-electron attraction. So if the proton-electron attraction is weaker, it has an effect on these measurements. So ionization energy is the energy it takes to take an electron away from an atom, and that energy depends on how well the electron is being attracted. And if it's being attracted not as well toward the nucleus, it's easier to take away, and ionization energy goes down. Electronegativity is a tendency to draw electrons towards yourself, and again, the thing that's attracting it is the nucleus. The nucleus is pulling those electrons. So if you have a decreased nuclear charge because of your effective nuclear charge, you're going to have a smaller electronegativity. And then the radius is the distance between the nucleus and those outer electrons, and that has a lot to do simply with energy levels. But because of our effective nuclear charge, our electrons are being attracted not as well, and it can become bigger. So to sum this up, essentially you have protons in your nucleus, and those are positively charged, and they're pulling electrons toward themselves. But there's something called electron shielding, and the shielding essentially increases the repulsion of electrons away from the nucleus and decreases the effective nuclear charge, which is how well the electrons are feeling the nuclear charge that exists. That's it. Have a nice night.